In this video, we will try to get more familiar with the LT Spice environment and at the same time refresh your knowledge in basic circuitry. We shall implement an inverting amplifier with a sinusoidal input, but before that, let me introduce to you the keyboard shortcuts in LT Spice. In the edit menu, you will see some shortcuts, some of which are intuitive. You'll get accustomed to these hotkeys as we progress with the course. So, do you still remember the configuration for an inverting amplifier? In case you've forgotten, an inverting amplifier looks like this. Let's start with the op-amp. LT Spice offers a variety of pre-installed components and models, from transistors to diodes and even integrated circuits. The components are arranged alphabetically for you to easily find what you need. By clicking on the model, a small description about it will be provided. For now, let's use a pre-installed op-amp. RH27C, a low-noise, high-speed precision operational amplifier. Next, let's add the input signal and the supply rails. In order to do so, we must first check the datasheet of the chosen device. We can see that it is a dual supply op-amp, and we should put in mind that its absolute supply voltage is 22 volts and that the input voltage should not exceed that of the supply rails. We can now proceed. For the input waveform, start by adding a generic voltage source. In the component menu, you can also type in keywords for you to easily locate what you need. Right-click, then choose Advanced. We now select Sine and input the necessary parameters. Now let's add the supply rails and the resistors. Instead of wiring them directly, we can use node labels to connect them. Also, we can further specify the type of node so that anyone can easily grasp and understand your schematic. Our circuit is almost done. We just need to input values and add some labels before simulating. Since we have equal resistor values, we expect the output to be of the same amplitude but inverted in terms of orientation. By clicking on the plot label, a cursor similar to that of an oscilloscope will appear. Clicking again will generate another cursor. Vertical and horizontal displacements are automatically computed, and hence, we can approximate the frequency and the peak-to-peak voltage of a certain signal. For a recap, which resistor value should we increase in order to amplify the signal given that the other resistor shall remain unchanged? We should increase the value of the feedback resistor R2. And that's it for our second video.